A living cell or the boundary of the observable universe are both finite containers. They possess limited space and limited energy, yet they produce endless, non-repeating behavior, generating infinite variation without escaping their bounds. This is the state of bounded chaos. In a continuous time dynamical system, it represents the ability to maintain complex, unpredictable motion indefinitely while locked inside a precise geometric limit. Every closed thermodynamic system faces two specific dead ends. If the internal motion is restricted too tightly, it freezes into static thermal equilibrium. If it expands unchecked, it dissipates into random entropic noise. Avoiding these two states requires a specific architectural mechanism to mediate the flow of energy. This mechanism cannot rely on randomness. To function, it must follow deterministic constraints that force energy into a specific recurring sequence. Sustaining life or a universe requires a closed loop, a mathematical engine that forces infinite recursion within fixed spatial and thermal limits. The Dual Caustic Universe Framework, or DCU, models existence through a sequence of operations called the 2-3-7 protocol. The mathematical equivalent of this protocol is the Rössler attractor, a chaotic system governed by three differential equations. We can map the operations of existence directly onto the system's parameters. The x-axis represents the baseline flow, the y-axis governs the accumulation of structure, and the z-axis enforces the boundary limit. This topological system is a minimal three-variable recursion engine. To function, it requires these three interacting dimensions to be present simultaneously. The Rössler attractor represents the structural isomorphism of the DCU's recursion engine. If we isolate the behavior on a flat plane, we see the baseline orbital flow. This is governed by the x-dot equation. The x-axis dictates a continuous circular motion. In the DCU framework, this is the light field, the underlying, unperturbed wave state of the system. This field is ontologically labeled Raḥmān. It is the baseline potential, the expansive force that pulls the system back into a stable, balanced orbit. In calculus, this topological orbit performs the function of the integral, known within the framework as the 7 state. The integral sums up accumulated changes to reconstruct the whole. It acts as the sustaining cycle that enforces a closed-loop return to the origin. The x-axis is the global anchor. It serves as the conservation law, ensuring that total energy and information are preserved, even as local states shift. To generate variation, the orbit must warp. This feedback equation introduces an outward-stretching spiral. The A term provides a positive feedback mechanism that amplifies the current state. This feedback causes the system to accumulate state space, building structural curvature and directional momentum over time. This structural accumulation is the sound field, or Raḥīm, the domain of directed propagation and continuity. Its calculus equivalent is the derivative, or the 3-state. It extracts the law of instantaneous behavior from the flow, giving the system its defined rate of change. By continuously accumulating structural memory, the y-axis assures the system does not fall into static repetition. When the x value crosses the threshold parameter c, the flat 2D spiral breaks into the third dimension, governed by the z-dot equation. The interaction of the variables triggers exponential vertical growth the moment the threshold is breached. This instability spike is the buffer field, or Razim, the physical filter that forces a measurement. This location in phase space is the boundary cusp where the accumulating potential hits a strict thermodynamic limit. In calculus, this vertical bifurcation is the difference quotient, the 2-state. The difference quotient creates two distinguishable states from a unified one. It is the mathematical mechanism of symmetry breaking, establishing the separation needed for work to occur. Reaching this peak forces a system reset, collapsing the trajectory back into the 2D plane. This z-axis spike prevents runaway expansion, dropping the system back into the x-axis return flow to begin the cycle again. When we synthesize these three axes, we see the complete operational cycle running simultaneously. A point traverses the baseline flow, accumulates structural curvature, hits the boundary threshold, and resets. The combination of expansion, compression, and return forms the architecture of a strange attractor. Because the lines of this trajectory never physically intersect, the system creates endless, non-repeating variations within its fixed container. This three-step geometric cycle allows a system to generate perpetual novelty without information leakage. This recursion engine is instantiated within biological rhythms. The human electrocardiogram, or ECG, exhibits a waveform sequence that shares this structural pattern. The baseline flow between beats mirrors the integral return. The structural buildup of voltage represents the derivative feedback, and the sharp QRS complex that triggers the heart's contraction functions as the boundary spike. We find the same architecture in abstract algebra, confirming that these rules are scale invariant. The semi-direct product shown here is the algebraic formalization of the 2-3-7 constraint. This group structure enforces a finite state space while permitting an infinite cyclical return. From differential topology to cardiac biology and abstract algebra, this three-stage sequence remains the structural signature of a self-sustaining system. This framework offers a specific perspective on the thermodynamic fate of the universe. The strange attractor provides an alternative to static equilibrium and entropic dissipation. Because each traversal carries the +c constant, a memory of the prior state, the system returns to its origin at a slightly different phase, evolving stage upon stage. A system collapse occurs only when a system fails to navigate the defined boundary of the z-axis spike. Chaotic variance and infinite complexity are dependent on these deterministic, unyielding boundaries. The configuration of flow, structure, and boundary defines the thermodynamic geometry necessary to sustain existence.